Sounds like you might be getting sick too.
Yeah, a little bit.
Wow.
It hasn't been too bad. Hopefully it won't get worse.
Fingers crossed. Can't afford to be sick.
I know. Well, how did it go for you?
I think it went okay. There were a few things that I was not sure if I was doing correctly, so I had to go back and read. And I'm still not sure if I'm doing it correctly, so I guess we'll see.
Okay. Yeah, I had a question on one of them too that I wasn't sure how to do it. Okay. Well, I guess the quiz is like the same questions, right?
I don't know. I haven't pulled it up yet.
I hope so. I'm just looking at it. Oh, it says we're supposed to take this once before meeting with our group and then a second time with our group. But I guess I'm just answering the questions was basically doing it, wasn't it?
Yeah. Yeah, it looks like these questions on here are somewhat what we had on the review. At least this first one is.
Okay, perfect.
Yeah.
All right, so the ones that are categorical. Sorry, I lost the thing there. Okay. Let's see. The number of animals in the local zoo, a randomly selected brand of toothpaste, age and years of randomly selected vehicle in a parking lot.
I wanted to say it was the second one.
Yeah. Not the age, the number of animals in the local zoo. Yeah, I feel like just that one. Okay, number 3, the mean IQ test score in the United States is 100. 20 randomly selected statistics students took an IQ test and the mean of their scores was 112. Which of the following statements is true? 100 is a parameter, 112 is the parameter, 100 is the statistic, and 112 is the statistic. So I think 100 is the parameter and 112 is the statistic.
Okay.
Is that what you think?
Statistic is 112, but when I did the parameter, I was unsure of that one, so I put that one as, what was it, 20 they had in here?
I looked up the notes and it was saying that the parameter is about the population.
Okay. Maybe I was last night. So yeah, okay.
Okay. And that statistic's about the I wrote it down. The statistic is about the sample. So I thought, let's see, so 20 randomly selected statistics students and their mean scores were 112. So that's like the sample.
Yeah. Okay, that's where I was getting that from. Okay, yeah.
Okay. Question 4. Rotham City has 4 distinct neighborhoods. The property values are very similar within each neighborhood, but they vary considerably from neighborhood to neighborhood. One neighborhood has very low property values and another has extremely high property values. Property taxes are usually roughly proportional to the property values. What type of sample should we collect to gauge the residents' responses to a proposed increase in property taxes? So I said stratified, and I don't know if you would think the same thing. I was trying to think of if they put like the neighborhoods are 4 different like categories, and then they randomly choose from each one of those.
Right.
Is that stratified? Because I always get these confused, to be honest.
I do too, and I went back and I was thinking maybe even like systematic or even like a cluster.
Okay, let's see. Yeah, because the cluster and stratified are very similar, so I never know Because the cluster in my notes, I say taking all items in one or more randomly selected clusters. And the stratified, they're organized into groups, and a simple random sample is drawn from each of these strata. So that's what made me think of stratified, because it's like they have the 4 groups, and then things are chosen from all 4 of those groups.
Okay. That makes sense.
Because I think a cluster is more like, here are all the groups, and then they randomly choose a couple of those groups and then choose within those groups. Maybe, I don't know. I don't know for sure, but that's what I think.
We can do stratified because that would make a little more sense.
Yeah, because if it's a systematic too, it could miss out on some of the neighborhoods, and only people from certain neighborhoods would be represented.
Right.
So I don't know. That's just what I think. Should we just say stratified then, or do you want to say something different?
I would say stratified.
Okay. Okay, so question 6, when designed experiments are conducted in a public school system, researchers typically choose a particular district and randomly select teachers of, say, 4th grade students in that district. The experiment is then conducted using all the students in the selected classes. Which type of sampling scheme is implemented?
I
wasn't sure.
Cluster.
A cluster?
Uh-huh.
Okay, that's what I put with a question mark. So I was like, I'm not sure.
Yeah, I actually put simple random sample, but then I went down and was reading one of the other questions, and I went back and looked at what a cluster is, and I'm like, wait a second, this one's cluster.
Okay, I think you're right, because it's like they randomly select. They just choose a district and then select the teachers. Okay, yeah, I think you're right. Cool. Then at a school fundraiser, the name of every person who attended was entered into a drawing. At the end of the evening, 6 names were selected to receive door prizes. Which type of sampling scheme was implemented? And that's just a simple random sample, right?
Uh-huh.
Okay. And then 7, a special interest group is conducting a survey regarding wolves in Yellowstone National Park to adequately gauge opinions on both sides of the political spectrum. The researchers took the list of registered Democrats and selected a simple random sample of 100 people. Then they took a list of registered Republicans and selected a simple random sample of 100 people. Which type of sampling scheme was implemented? I think that one's stratified.
Physics, I put on here cluster.
Cluster? Okay, let me see.
Yeah.
So with stratified, it says when items to be sampled are organized in groups of homogeneous items, which makes me feel like it's the stratified, because cluster I think is kind of more random. And in this, it's like all the Republicans and all of the Democrats.
I don't know why I put that, because I actually specifically remember looking at stratified when I looked at this question. So maybe I wrote it down wrong.
Okay. I think stratified makes
more sense, yeah.
sense. Okay. Question 8. A survey was taken, crossroads, okay. Using software, calculate the mean of the amount spent. So I got for that 4.771.
That's what I got too.
Sweet. Calculate the standard deviation, which I got 1.911.
That's what I got too.
Okay. Start by creating a histogram of the amounts, then mark the following statement as true or false. I created a histogram. Okay, yeah. Got that. then 11. All right, I'm not going to read all of that. What is the value of the number that goes in the position marked with an A in the table above?
Wouldn't that one be 38.07? So if I remember correctly, you add up all of the numbers in column A and then divide it by how many numbers there to get. Or are they looking for 37.91 minus 38.07?
Yeah, I think that's what it is. Because I got negative 0.165.
Okay, so they were looking to solve it. Let me solve this really quickly. You got negative 1.37?
No, I got negative 0.165.
Oh, that's why I'm adding in a different number.
Oh.
So 37.91. I get negative 0.16.
I can't remember. What was the mean? I didn't write it down.
I got the mean as 38.07.
Okay, let me see if that's what I got. So I got 37. I'm just going to redo it real fast. Yeah, for the mean, I got 38.075.
Maybe that's what I'm doing wrong. Because I'm not adding a 5 at the end of this. 37.9. So yeah, if I add on the 5, I do get a negative 0.165.
Okay. Since it wants the answer to 3 decimal places, I think we should just keep it at the 5 at the end.
Yeah.
Now, what is the value of the number that goes in position marked with B in the table above? And then what do you do for that?
That one, I got a negative 0.6724.
Okay.
But if you round it up.
I didn't get a negative. I got 0.681.
Really?
And now let me, because if you take.
And it's probably because I didn't add that 5 to the end that I'm getting this answer.
Oh, yeah.
So let me see, 37.25. Yep, that's exactly it, because I get the negative 0.680. If you round that up, it's a 1.
Okay. Let me see. 0.825 squared. I don't think it should be a negative, though, right? Because it's squared. And so it makes it a positive.
That's what I'm getting.
You got a positive or you got a negative?
I got a negative.
Did you put it in parentheses?
Mm.
You did?
No, I didn't.
Oh, okay. So yeah, if you put parentheses negative 0.825 squared, it should be a positive.
Okay, so if I do it that way, then yeah. But if I square it the way that I normally have with my calculator, it was giving me a negative, which is funny. Because you'd think you'd get the same thing.
Yeah, it's weird because if you ever square a negative number, it should be a positive number, right? Because if you times two negatives, then it's a positive.
Yeah.
Okay, so 13, what quantity is equal to the sum of the numbers in the squared deviation columns?
I want to say the variance.
Oh, good, that's what I said too. It took me a while to come to that, but yeah, that's what I said too.
Okay.
And then what is the standard deviation of these temperatures? So I got 0.854.
Yeah, I got 0.034.
Okay, so that one. Because we have to, I took a picture of how I did this one. So I'll show you what I did here. You can, is that going to show up? Or is that backwards for you?
No. Okay, so you basically did, I did the same thing. And then what's the bottom? I can't see.
And then on the bottom, so you take the sum of all of those, and then you divide it by 4 minus 1, because you do n minus 1. So you divide it by 3, and then you square root it. Or you take the square of it.
Okay.
And so that gave me 0.854.
Yeah, that's not how I did mine. Because I did my first the same way that you did yours. But then, if I remember correctly, I think I took all of the sums and then divided it by 4. So that's where I went wrong.
Okay. Yeah, I went back to that chapter and looked at it, and it said to divide it by n minus 1.
Okay.
So it's 4 minus 1. So you divide it by 3.
See, and I couldn't find that when I did that, so.
It actually took a while for me to find it. Because the steps they weren't way clear. It was really frustrating, actually.
Okay. I'll have to go back and reread that, I guess. Make sure
It's tricky. That's one of my least favorite things we've done so far in this class. I don't like it.
No, you're all right.
Okay. Should we keep going then, or do you want to do more on that?
No, I can go back on that one.
Okay. Okay, so under normal or under certain conditions, the standard deviation can be negative, which is false.
Really, because I went back in and I was trying to find an answer to a different question, and somehow I found where it said it can be negative.
Oh, really?
Yeah, but I thought I remember reading at first that it was false, that it can't be negative.
Yeah. I wrote it down. Yeah, I wrote in my notes, standard deviation cannot be negative.
I did too.
I remember talking about it. Do you remember where it said it can be?
I don't.
Okay.
I don't even remember which question I was looking that up for. But yeah, I originally put false, but then I thought I saw something that said it was true.
Okay. And that might be the case, but I think I'm going to stick with false.
I am too.
All right, 16. Which location resulted in the most consistent temperature measurements from one field to another? So I put the extradural.
See, in this one I put arterial. And the only reason I did that is because I thought that it was the higher the number.
So it's the lower the standard deviation, then the data is going to be closer together. Because if you have a larger standard deviation, that means they're spread out more.
Right, okay. See, and that one I wasn't too sure of either. So I'm like, wait a second. And I couldn't find anything on it. So I'm like, eh.
Yeah. So if you just think of like the standard deviation, the smaller it is, the closer they will be together, which means it's more consistent.
Okay, that makes sense.
Okay. And then for number 17, what is the third quarterly? And I put, which question was that?
I'm trying to find that too. Oh, that was 18.
8.
So
okay, yeah, so it's 8.
I put 8, yeah.
Okay. What percentage of the data lies between 4 and 6 hours? Note, list the number as a percent and not a decimal. I don't include the percent sign. Okay.
Okay.
So I think I put 75%, but I wasn't completely sure.
Really? I wasn't completely sure on that either, so I put 25. But if I remember correctly on the homework assignments we were doing, they counted where you have the bar that starts. So you're probably right. It is probably 75.
Okay. Because I was like, if it has the 3 quarterlies in it, then I would assume at least 75% would be in it.
Yeah.
But I wasn't sure. Just stick with 75 then. Okay. All these questions. Okay. Number 19. Estimate the mean of the measured nitrate concentration in Rexburg's drinking water. I got 2.055.
That's what I got too, and I wasn't sure if I did that question right either.
Oh, good. Okay. Well, good. Okay, and then estimate the standard deviation, which I got 0.233.
That one I got 2.906. And I wasn't 100% sure on how to calculate that. So I just took our mean and square rooted that by 2.
Okay. I'm trying to remember how I did that. I just wrote down my answers and I used a whiteboard, so I probably erased it. Okay, let me think. Standard deviation. Oh, I remember how I did that. I hope I took a picture of it.
Because I remember the standard deviation, you take, what was it, like the sum and then divide it by, what was it? It was in one of our meetings we did. I remember clearly doing it.
I probably figured it out a very difficult way, but I'll show you how to do it. So okay, so I made this like little graph with it. So I put the mean in the middle, and then the lowest one and then the highest one, I put that as 2 standard deviations over. Okay. So the difference between this and the highest one was, let me go back, 0.465. And so if you divide it by 2, that gave me this number. So if you divided it by 2 and added it to this, it gave me that. It gave me that.
Okay, so
But so that's how I found the standard deviation. So I found the difference between this big number and the mean, and then divided it by 2 to get the standard deviation. And then I checked the math, and that was how they all fit. And so that's how I did it.
So, okay, so if I take the, let's see, I'm trying to calculate this. So 2.055, add that by 2, I get 4.055, which you said you got, right?
Got what? Sorry, say it again.
4.055.
I didn't get that. So if you take 2.52 and minus the mean of 2.055, I got 0.465, and then divided that by 2, and I got 0.2325.
Okay, see, I'm taking the 2.055 and adding 2 to that. So you took the high. Okay, so 2.52 plus 2. So I do get 4.465. And then you said you divided that by 2. Yep, and I get 1.49.
You added 2? Why'd you add 2?
What I add? I minused 2. That's what I wanted to say.
So all I did 2.52 minus 2.055, and then got that answer and divided that by 2.
Yeah, that's what I'm doing on my calculator. I'm not saying it right.
Oh, okay.
I'm trying to write and say this at the
I
know. 0.055. Okay, divide you by 2, which gets 1.492.
1.492.
Uh-huh.
Tell me again what you did. Because I'm getting something different.
Yeah. So I took 2.52 minus 2.055. That's where I get 0.465.
Mm-hmm.
Okay. And then you said you divided that by 2.
Mm-hmm.
That's where I'm not adding this together. I forget that you have to do your first step first and then divide after.
Oh, yeah.
I'm so used to doing it all together.
Yeah.
So 0.2325.
Yep. And if you round it to 3 decimal places, it's 0.233.
Yep.
Perfect. So then the next question, between what 2 measured concentrations do 68% of the data values lie? We just add and subtract the standard deviation to the mean. And so I think it's 1.823 to 2.288 is what I got.
Okay. See, I did this differently. I didn't even do the standard deviation because I thought through the examples that I could find through the readings, you just take the 1.559 and then subtract and then add. That's what I did.
Oh, okay. Well, because when I drew this, that's really what helped me, because then I can be like, oh yeah, the 68% is from one deviation to the other deviation.
Yeah.
That's how I did it.
Your way seems so much easier than what I found in the book.
Well, hopefully it's right. That's what, it makes sense to me. Okay. Let's see, question 22. What is the probability that a randomly selected student would score above 542.3 on the GMAT?
That one.
So I thought it was like a 50% probability. because I got a z-score of 0.
Did you? I didn't get a z-score of 0.
What'd you get for your z-score?
I got, if I'm looking at this right, 0.3628.
Okay, how'd you get that?
So what I did was I took the 500 minus the 542.3 and divided that by 120.54.
Okay, let me think. So that minimum. So 500. So, okay, let me read it out. I think that's the z-score of if somebody scored a 500.
Okay.
Because this is like, what's the probability that a randomly selected student would score above 542.3?
And then I thought we were supposed to go through and take it to the applet and figure out what it beat. And that's what I was.
So that's what I did, but I found the z-score of 542.3, which would be 542.3 minus the mean, which is 542.3, which equals 0.
Mm-hmm.
So that's why I got the z-score of 0, which means, and then when I put that into the probability applet, then that means there's probability of 0.500 of scoring higher than that, which I think makes sense. If you have a mean and what's the probability that people will score above that, it should be at 50%.
Yeah.
Does that make sense or does that not? I don't know.
Yeah, it does.
Okay, I think I'm gonna keep it at 50%. It seems weird to me, but I'm gonna keep it at that, I think. So the next question was the probability that a student would score 600 or below. What'd you get for that?
So for that one, if I'm looking at this right, once I put it in the applet, it was giving me the answer of 0.316.
Okay. I got something different. Let me type in my z-score again. What'd you get for your z-score?
The z-score that I got was 0.479.
Okay, me too. So let me look at it. And the random will score below 600. Oh yeah, so I got 0.684 because you shade the area from the positive z-score and down.
Right.
Which gave me 0.6840.
See, and when I was doing this last night with the applet, it was being funky with me for whatever reason.
It does that to me sometimes too.
I'd exit out and exit in like a zillion times, and I still got the same answer. So I'm like,
Well, that's close to what I got for scoring above the 600, which is 3.16. Or sorry, 0.316.
Yeah. So when I put in that to the applet again now, I do get the 0.684.
Oh, okay. Perfect. So then to find the other one, you just shade the other part or subtract 1 minus 0.684, which is 0.316.
Is it 0.316?
0.316, yeah.
And this is above that. Why am I not getting this as the answer?
What are you getting?
So if I shave it above, I get the same answer as the first one.
Another way you can do it is just subtract 1 minus our answer to question 23, which would be 0.684, which equals 0.316. I think maybe that applet's being weird again for you. I'm sorry.
Yeah, it is. It's being completely weird. So you said to take the 0.684 and minus 1?
So you do 1 minus 0.684.
0.684. Let's see what I get. Okay, so if I do that, then I get 0.316.
316? Perfect.
Yeah.
Okay. Okay. So then number 25. What'd you get for that?
For this one, that I could not get the 10th percentile for the life of me. It was giving me the same answer for the percentile as the 90th.
Oh, weird. Okay. Well, when I type in the 10th percentile, the z-score I get is 1.282.
Yep, that's what I got.
Okay, perfect. So then for the answer, I got 387.768.
Okay, let me, because I wasn't sure if that was even the correct one, I didn't
Yeah.
really complete it all the way. So 125.4. And you said you got what?
I got 387.768.
Okay, so I must be missing a step because I'm getting 696.83. So if you times the 120.54 to 1.282, I get the answer.
Oh, sorry. For the z-score, it's a negative 1.282. So if you have the negative 1.282 and times it by 120.54, and then you're going to add 542.3.
Okay, so yeah, I still get 696. What am I doing wrong?
696, that's the answer for the 90th percentile. But if you think about it, the 10th percentile is 10% if people are going to score yours or lower.
Right.
So it should be a low number.
Right. And that's what I figured too.
So did you make your z-score negative?
Yeah.
So if you do negative 1.282, let me do this in my calculator. Negative 1.282 times it by 120.54.
Okay, so that gives you a negative 1.54.53228.
Yep, and then you're going to add 542.3.
Okay, so if I do it that way, then I get 387.7672.
Thanks. And then for the next one, for the 90th percentile, you do the same thing, but don't make it a negative. It's a positive z-score.
Right, okay. Okay. So find the first quarter percentile for that. Next question, which was 29. So I got 21.69.
So I got 461.056. So for this one, to find the z-score, I typed in 0.25 at the top. And then, yeah, of the applet. And then the 25th percentile would be everything lower than the negative one. So the z-score is negative 0.674.
Wait, it's lower than the negative?
Yeah, because it's find the first quarterly. So the first quarterly is the bottom 25%. So it should be a negative.
It reset on me. That's why I'm like, wait a second. Negative 0.64. Okay, so for the third quarter, why are you giving me the same answer?
The same answer for the third quarterly?
Yeah.
The z-score is the same, but it's not negative this time. It's a positive.
Okay, so you're saying that is a positive 0.674.
Yeah. So you take that and multiply it by the 120.54 and then add 542.3. So I got 623.544.
Let's do this. Because that's not what I got. Because I did this a different way. Because I thought when I went back and looked that you're supposed to take the 542.3 and divide that by the quarter. Maybe I thought of this wrong when I was doing it last night. So I got a 7.230.
7.2.
Yeah.
Okay. Well, when you like a good way to check your answers is like if you look at your answer and if you go up here, all the scores should be around like 500 to 600. And so if you're getting answers that are only like 7, it doesn't quite make sense.
Right, yeah.
So it's just an easier way to kind of check your answers too.
Okay, so and I couldn't find anything last night on how to do this problem and figure that one out either. So I was like, this is the only thing that I could see.
I think it was in the homework of one of them, but it wasn't one that we spent too much time on.
Oh, was it?
I think so, but I don't remember.
All right, so you said that you took the negative 0.674, and you said you added that?
So, sorry, which one are you doing, the third quarterly or the first?
I'm doing the third quartile.
Okay, so the third one, yeah, is the positive one, so it's 0.674.
Uh-huh.
And then you're going to multiply it by 120.54. And then you're going to add 542.3.
Okay, so 0.6. And then add 120.54. Okay, you said you got 201.78?
No, I got 623.54. What kind of calculator are you using?
I'm using the calculator on my phone. Because my
Okay.
calculator's over on my desk. And
So it might be worth it to use the graphing calculator because it makes it a little bit easier.
okay. I wonder if maybe my calculator on the computer might give me something different too. Let's see. Yeah. Calculator on here gives me the same thing. Hold on, let me grab my calculator, see if it'll give me something different.
Okay.
Okay. Even my calculator is giving me the same thing.
What are you getting? 120?
I'm getting 201.78.
Okay. Well, it can't be 200 because it's between 500 and 400. So let me show you on my thing what I'm doing. So for the third quarterly, the z-score would be 0.674. So you times that by 120.54.
Mm-hmm.
So that's 81.24396.
Yep, that's what I got.
Okay, and then you're going to add 542.3.
That's what I'm doing wrong. Yep, 623.52. I'm adding 120.54. That's what you said you had.
Yeah, sorry, you have to add the mean.
Okay, there we go. That's where I'm going wrong.
Okay.
All right. 29.
Okay, so consider a simple random sample of n equals 15 students. What is the mean of the distribution of sample means? What'd you get for that?
For this one,
I put 542.3 because the mean should be the same, right?
yep, that's what I got. Making sure I was looking at the right question on my paper.
I know it's confusing because the numbers are different.
Yeah.
And then for the standard deviation, I got 31.123. Because you take the standard deviation and divide it by the square root of the sample size.
Okay.
And the standard deviation was 120.54. And you divide it by the square root of 15.
Yeah. Okay, hold on. Let me see if I get that. Oops. Okay. Okay, so this one, when I add this up, 0.001.
0.001.
Yeah.
Okay, so we need to just take the standard deviation, which is 120.54, and you divide it by the square root of 15. So even if you take just the square root of 15, so that's 3.872983346.
Okay.
So take 120.54 and divide it by that. I'm still getting 31.123.
I'm doing my math wrong again. So yeah, I get that 31.123.
Okay. And then last question, what is the probability that the sample mean score of blah, 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 blah will be greater than 600? So I got 0.032. So I used the formula where it's the value minus the mean divided by the standard deviation.
Right.
So I got 600 minus 542.3 and divide that by the answer we got for question number 30. So my z-score is 1.853917. And then you type it into the applet. And above, so you shade above. So I got 0.0319.
Okay. Let's see if I can get that one. Okay. That's what I get to.
Perfect. I missed a couple questions, but I'll just have to go over that because I'm so sorry. I really need to run somewhere.
No, you're fine.
But do you have questions about anything for me?
No, I've been going back through to reread everything to make sure I 100% understand it. So
Yeah. I'll have to do the same. Okay. Well, thanks, Ashley.
yep. See ya.
Okay, I'll see you Thursday.